Why is it so challenging to reach Saturn? Since the beginning of space exploration, only 4 spaceships have succeeded in getting to Saturn. But only one was able to reach the planet's surface. Disclose what's under its bowels, and clouds were everywhere. Is it challenging to reach the planet using the enormous asteroid's rings? Ready? Let's get going. Introduction: the 6th planet from the Sun in proximity. Nevertheless, the well-known asteroid on Saturn is well-known. Rings, yet despite its notoriety, not many the vessels that have arrived at this remote planet. Thank you for visiting KYC News. Please subscribe and click the bell icon. The giants of gas. One of the primary causes of Saturn's difficulty pertaining to our spacecraft or space exploration rovers, the fact that it is a planet, makes it worth visiting. Named gas giants, which are incredibly far away from the Sun and Earth. Any spaceship intended for the furthest the solar system's planets must adhere to certain requirements that are extremely challenging to meet. A condition of this nature is that the spaceship must possess a nuclear power source, that it has electricity for all of its data transmitting works. These batteries must be carried by these ships, as opposed to conventional solar panels, because these planets are too far from the Sun. Thus, there is very little light, and the insufficient energy is produced by solar panels for the ship's operation. The lack of light necessitates this, because to include nuclear-powered batteries heating energy. However, these batteries have a drawback, that is that they are really heavy, which moreover, the cost of the spaceship rises. Due to the fact that the more heavy something is, compared to other vehicles, it requires fuel to travel far. Compared to the power used by exploration probes that employ solar energy. Beyond Jupiter and Saturn are gas giants. The asteroid belt, where temperatures are extremely low, which explains why ships who are dispatched to investigate these planets must possess isolation mechanisms for low temperatures of the extraterrestrial medium. Of course, one of the most crucial factors is arguments for why it is difficult to reach Saturn include that distance from Earth is 1,300 million kilometers. This distance requires a significant amount of fuel and energy are required at the moment of, due to the fact that the probes that have visited Saturn have received assistance from Jupiter's gravitational support too far away for telescopes. Saturn appears as a yellowish planet when viewed from Earth, one of the night's brightest objects. Sky. Using a telescope, the 2 most massive A and B class large rings are readily identifiable seen. The 2 minorest, denoted by the letters D and E, are only seen when the atmospheric conditions are ideal. Before the telescope was created, Saturn was merely a different planet in the sky. It, the farthest of all, is well known to be. However, there were no additional details about it or regarding its belts of asteroids. The first person to notice the rings was Galileo. Yet, the low inclination of the rings in 1610 and his telescope's poor resolution initially made him believe they were big moons. Christian improved his observing techniques. Huygens could see the rings in the 1659. James Clerk Maxwell demonstrated theoretically in 1859 that rings couldn't possibly be one complete piece, but must be a collection of millions of smaller objects, particles. Today, we are aware that the constituents of the majority of Saturn's rings are made up of pieces. They are made of ice and rock, and they revolve at a 48,000 kilometers per hour speed, 15x more quickly than a shot. Cassini missions 4 U.S. spacecraft significantly increased Saturn system knowledge. The Pioneer Voyagers 1 and 2, 11 probe, and Cassini-Huygens spacecraft probed these satellites carried equipment and cameras to assess the polarizations and intensities electromagnetic spectrums of radiation, radio, visible, ultraviolet, infrared regions. Moreover, they had equipment for magnetic field research and detection of electrically charged atoms and planetary dust grains. 11 Pioneer first ever spacecraft to make a stop at Saturn was Pioneer 11, one of the initial NASA's space exploration program's probes. On April Cape Canaveral launched it. 5. 1973. After leaving the asteroid with success on April 19, 1974, the speed of the belt was changed in order to put Jupiter in its path. On December 4th, during its flyby of Jupiter in 1974, it created an image of the Great Red Spot and initial polar region observations and figured out the satellite Callisto's mass. He entered Saturn on September 1st, 1979, capturing the initial close-up pictures where he discovered two new species, other rings, and satellites. It persisted after its run-in with Saturn, studying its path away from the solar system, the energetic particles of the solar wind. Naturally, the Pioneer probes received their energy from a source of radioactive isotopes, RTG, rather than solar panels. The ships were powered by these generators, so once in 1995, they ran out and ceased to operate. Similarly to how the Pioneer 10 probe and later, with the Voyager spacecraft, the Pioneer 8 plaque was present on the 11 probe's construction, describing the origin of the probe to a potential culture of extraterrestrials. A man's figure is depicted on the plaque, and a female, the hydrogen atoms transitions, considering the Earth's and the Sun's positions in the galaxy, whose purpose was to convey a message from the race of humans to a potential extraterrestrial future race that will locate the ships and successfully interpret the information therein around the disks. The two Voyagers prior to the advent of space exploration, only Saturn's largest satellites like Tethys, Titan, and Enceladus Dione, Geppetto, or Mimas, were known. Still, the exploration probes Voyager 1 and 2 managed to make important discoveries about these satellites that until then were unknown. Among these discoveries, it was possible to confirm the existence of large amounts of methane in Saturn's biggest moon, termed Titan. They were also able to see enormous geysers, sprinkling the target with a lot of ice and water. The Enceladus satellite. Titan and Enceladus are both fascinating objects. Planetary scientists since the earliest conviction is the potential for liquid water to exist depending on a small depth below its surface, the water vapor that geysers release, and the second displays a climate full with methane and gases akin to those in the prehistoric Earth. Similarly, the initial high-definition photos of Saturn were also captured, displaying a golden hue with black storm-line streaks that took place in its environment. Huygens Cassini. This was Saturn's most active and sustained period. On this planet's mission, two new satellites were discovered by this spacecraft, Pallene and Met1, which are both extremely tiny and have erratic forms. These two satellites were found by Cassini. Phoebe flew by the moon and took numerous shots. Then, taking various measurements of its surface, it enabled us to determine that this tiny moon of Saturn's surface may contain water. Exploring Titan, it was drilled by the Cassini-Huygens spacecraft. Since it is an orbiter as well as carried a spacecraft for terrestrial exploration, the Huygens probe would undock in this instance. From Cassini to touch down on Titan's surface, the biggest moon of Saturn. The Huygens probe was successful on January 14, 2005. Landed on the Titan's surface in an area called as Zadiri, taking pictures as it descended and at first glance. The view from the plane as it descended is lovely. Drainage canals on slopes. The pathways appear to lead to a small, large, an area that is dark, flat, and where you may see in shoreline, including any islands, and what a hazy sea of what appears to be methane desert surroundings. According to ESA experts, the probe could have settled over the shadowy area of Titan. A flat is visible in the photo taken after landing. Stone surface covered with spherical stones pebbles. The majority of the pebbles can be formed of water. Ice. Not to be overlooked is the fact that on Titan, nevertheless, there is no liquid water on its surface. There is frozen water, there is such ice. The shape of rocks. After arriving a week prior, Martin Tomasco of the University of Arizona, the organization in charge of cameras from Huygens, said, "We now possess the key." to understanding what sculpts Titan's environment. The precipitation-related geological evidence, river action, mechanical abrasion, and erosion that has sculpted Titan is very similar to that the Earth's past has shaped it. Images acquired from the probe of Titan display an intricate system of small drainage tunnels that flow from the luminous mountains down to darker, flatter lower regions. A striking number of lakes, coasts, and islands exist. They are comparable to those on Earth, and it even rains, but methane rather than water as on Earth. But this is where the parallels to Earth end. Titan is a planet where the cold temperatures prevail, of minus 179 degrees Celsius in a nitrogen environment. Methane, too. Its methane takes the place of water on there. The Earth is creating clouds in its atmosphere. When it condenses, a methane shower is created. Particles that flow in the streams and fill them black substance nonetheless. The lakes and valleys are currently dry due to methane seeps into space like water does on Earth. Beneath Titan's soil, leaving behind organic remnants, surface-level substance. Investigating Enceladus following the Voyager probe encounters early in the 1980s, planetary scientists proposed that Enceladus might have active geology, given that it has a high albedo, which denotes a new surface, and its position in the middle within the E-ring. Maybe via a mechanism involving water vapor elude the interior. In 2005, information from several instruments, the Cassini probe, provided evidence for this hypothesis. He also discovered potential deposits of erupting liquid water at shallow depths as geysers on Enceladus' surface, which one of the most significant findings of the mission, as well as of history, the exploration of space. Ice is visible in Cassini's high-resolution pictures. Massive particles are ejected via jets and tall ice spikes fast from the surface of Enceladus. Many theories have been put forward to this method. The jets escape, according to data and models, shallow water deposits from the liquid surface. The evidence supporting a subterranean ocean of between 30 and 40 kilometers of liquid water that this moon is expanding beneath the surface is a fact. Yet, a recommended substitute for such a large ice tunnels filled with the ocean may exist: water. Newer models demonstrate that it is geological activity and the proposition that it is only subject to tide forces. It can be better described if you make the assumption that a geological feature of this kind, which makes this little moon, is a good candidate for a search target for the existence of alien life. Saturn's exploration is over. The final spacecraft to launch was Cassini-Huygens. To investigate Saturn, this mission concluded in 2017 when the spacecraft started to run out of electricity, and researchers considered numerous ways to end it, including forwarding it to travel into space before colliding with Saturn to prevent any biological contaminating exposure to other satellites that might support life. Ultimately, it was determined to interfere with the probe. In opposition to Saturn, as with the Juno and Galileo probes after its Jupiter-based mission was over, in doing so, it made use of a space that separates the planet from it is surrounded by an asteroid belt. It made 20 orbits and then slammed into Saturn, burning and become dust in its atmosphere. To profit, this choice was also made. Of the ship systems that were still operational working, it was because of this that they assemble crucial information on the clouds of Saturn's influence today aids in some understanding improved operations of this gas behemoth. There are no longer any spacecraft now investigating, but a brand new mission named Dragonfly to Saturn. Plans call for sending a robotic drone in 2027 to investigate Titan's surface. Would you like a video about this made? Mission to space? Comment below with your thoughts to let us know.